Hello all, how are you? Welcome to the ANSYS CFD course. Let's start today with interface of the ANSYS Workbench and also check how to open all of the programs that we need, like the geometry, the meshing, the CFX or Fluent, also the CFD post or the results section. Here in this video, as you can see here, this is the ANSYS Workbench. When you search for the workbench for the ANSYS, don't search like ANSYS like this. You will find that this is ANSYS help. This will not open to use the ANSYS Workbench. Just search for Workbench. When you search for Workbench, you will find that there is Workbench according to the version that you have installed in your computer. So just open your Workbench. Opening the Workbench is, as we mentioned before, that it's including all of the parts. Like here there is analysis systems for CFX, for Fluent, and also there is some component systems, so we can just go over and check everything here. But you must know that actually you can work without the workbench itself. You can just search for CFX. You can open CFX as a separate program, or we can just open Fluent. Any program of these is just a program that you can open separately without the use of the ANSYS Workbench. The ANSYS Workbench is just uh, an interface that can combine multiple programs at the same time that are included inside ANSYS. So I prefer always to work with ANSYS Workbench to connect multiple analysis systems. But if you prefer to work on CFX, for example, import your meshing from any external meshing module, then work with the setup, the solver, and if you have a turbo grid with at the end CFD post. So actually here in this part you don't have any way to do your meshing or draw your geometry, just import them. Okay, so you have two options: work as separate for CFX or Fluent, or work inside Workbench. I prefer Workbench, as I mentioned earlier in this video. Let's check what is the interface of this Workbench. As you can see here in the interface of the Workbench, you will have file, view, tools, units, extensions, jobs, and helps. In the project tab here, this is the project tab that we put all of our analysis systems here. You can get from the toolbox on the left hand side an analysis system, like a coupled field static, a coupled field transient, whatever you prefer. We will use an fluid flow CFX or fluid flow Fluent. This is a complete analysis systems, starting from the geometry and finishing with the results section. But also you can see there is another part called component systems. This one is separate systems, like a CFX, just the setup of the CFX and the solver, just the Fluent setup or solver, just the geometry. So actually in this part you take just one of these modules. So we can work with analysis system or component system. What is the difference between them? Let's check it together. If you wanted to work with fluid flow CFX, just drag this one and put it at the location you prefer. So it will create a standalone system. This is an analysis system for CFX fluid flow. You can see here you will start drawing your geometries and mesh, setup, solution, and the results at the end. Also you can use fluid flow Fluent in case you prefer to work with Fluent as the solver for your case. So it will be the same, just the only difference is in this part here for the setup and the solution. For the analysis system A, setup and solution will be for CFX, but for analysis system B it will be for Fluent. Okay, so this is just the analysis system. It will be, as you can see, a one bulk part that you can work with. But if you work instead of analysis system, if you work with here, if we work with component systems, we can see here that in the component systems we can just take CFX or just take a geometry. So if we zoom in here and check, if we used like the geometry here and put this geometry at this part, you will see that you will draw your geometry here, just the geometry, without any meshing, without any setup, solver, or results. You can take one of the meshing. You can take one of the component system like the CFX. You can put it at any location between any of the systems that you have, or just at a new part here. When working with component systems like this, you can connect a geometry here to this part, so the geometry drawn in this analysis system will be imported to this part, so the meshing will work with the geometry used in analysis system C. Also, for the setup, you can, if you drag for the meshing, and then you will see that there is a green dotted box over the parts that you can connect it. So if we transfer it to this, transfer this read to E here, you can work with the mesh inside this setup. So actually, you can work with analysis system a complete bulk part for CFX or Fluent, or just work like this from the geometry and then connect the geometry to the mesh, and from mesh to the setup and the solver. Also, you can put at the end a results section like this. You can work with different solutions and compare it in the same results. Like if you connect this solution to a geometry like to the results here, also we can connect this solution to the same results. We can take this solution to the results here. You can connect multiple solutions to the same results file at the end. Also, in case you have you want to use the same geometry for different mesh, or use the same mesh for different setup, you can work with it like this. If we take another meshing, like for example, if we put it here, we can connect the geometry to a new analysis system G. So the same geometry drawn here, if it is updated with a new one, it will be updated inside analysis system D and also for analysis system G. So it's very beneficial to work like with a component systems like this, because you can work with just one geometry and affect this geometry on another analysis system in order to check whatever the difference in the meshing. Like you can call this to be, instead of mesh, just mesh 1, and the next one is like mesh 2. When we work with the meshing, actually we don't know what is exactly the best meshing, so we always try to change the meshing and check the statistics of this mesh to be as much as possible compatible with having a perfect mesh that can give us at the end a better solution. After that, we can also use another CFX. Like for example, you can use different turbulence model, so you can check for this analysis system E. We can call this one CFX with one of the turbulence models like K epsilon. We can call another one, we can call this one analysis system HCFX. Instead of K epsilon, we can use K omega. So actually, you have the ability to change and put whatever number of analysis systems as you want. Also, we must connect the meshing to the setup. So it's very beneficial to work with component systems over analysis systems. I always prefer that. Okay, so this is just the interface of your project. In case you open any of these programs and add a parameter, like for example, let's try a simple one like this one. If we open ANSYS space claim in order to draw whatever, I will do another video for the space claim, how to draw on space claim, sketching, and also the 3D modeling. But for this video, I will just draw a very simple sketch fastly, and then check just the parameter, how this will be shown to us inside ANSYS, because actually most of your work will have something like a parameter for one of the dimensions in the geometry, or one of the meshing components inside the meshing module. Okay, now after opening the ANSYS space claim, we can just draw, like I prefer to draw something simple, like just a circle. This circle, I will pull it and make it a 3D model. So let's put it with a specific parameter, like we can just make this disk has you can see here that you can pull it at the distance you prefer. Actually, when you select, if we return back, when you select any of these faces and then drag it to any location, you can see here there is b shown here. When you click on this b, it is added as a parameter. So now you have a parameter for the thickness of this disk. So when we go to the groups here, you will find that there is group 1, which is 2.91 millimeter. This group 1, we can name it as we prefer. We can rename this to be thickness. This thickness is of a dimension 2.91. You can change this, of course, to any thickness you prefer, like 6 millimeters. So you will see that it's changing at the same time. Now if we return back here, you will find that the geometry here, there is another part called parameters added below the geometry, and this parameters is connected to parameter set. When you double click on this parameter set, actually this parameter set contains the parameters that you have in this part, which is b1 parameter 1. It's a thickness of value 2.91 millimeters. This is the previous value. When we update, it will be updated to 6 millimeters. Okay, so just the tabs here, you have the project and another tab called parameter set. Whenever you add any parameter after that, like in the meshing, the parameters will be added also in the parameter set. If you add a parameter in the setup, it will be added in the same section. When you open this part in the parameter section, here you can see column A, it's the parameters. If it is an input or output parameter, you can add a separate parameter inside ANSYS, not just inside the space claim. The name of this parameter, it's called the thickness, the value of this parameter, and the unit of it. You can change the unit, very simple, inside the ANSYS Workbench. Also, there is some beneficial parts here. We will check it later for drawing a chart for changing any of the parameters. And the table of design points that I have mentioned in the first video, like this one, table of design points, you can add the first column here is the name. The name here is design point 0. It's the current design point. The first parameter is the thickness, it's 2.91. If you added an output parameter, it will be shown here in the table. So just when you update all of the design points, like if you want to add a new design point, instead of having thickness 2.91, we can check if this thickness is 6 millimeter. And then let's try if the thickness is increased to 15 millimeters. It is design point 1, design point 2. Take care that each design point will be updated, but you will not have the results as a separate file that you can work with after that, except if you checked this part. This part is called retain all of the data. When you retain all of the data here, retaining the data means that you save each design point as a separate results. So in case you want to check any of this design point in deep details, not just checking the value of the output parameters, I prefer always to check this retain part to have all of the design points saved as a separate files. Just when you do this, in order to update your design points, you will here just press on update all design points. Updating all design points will work from design point 0 and then design point 1, 2, and so on. In case you have finished updating all of the design points, you will see all of the output parameters listed as in this table, and then you can select, when you press on retain data, you can right click and select this as a current design point, because actually these three design points are the same. It's just the difference is the parameter value. So in case of design point 0, the thickness is 2.91. So currently when we update the project, the design point 0 will be working for this analysis system C of 2.91. In case we have changed the design point to design point 1 and set this as a current design point, you will see that some edges will close. You can see that when design point 1 is current, the parameter section, the parameter or the first parameter of the thickness will be 6 millimeter instead of 2.91. So when we set any design point to be current, so currently this geometry is for 6 millimeter of thickness. So the analysis system will be the same. It is not another analysis system, just the value inside this analysis system is changed according to the one that you are currently working with. If you uncheck this retained data, you will see that you cannot set this as a current because actually you don't have a results. You don't take care about the results to be saved. It will take a larger space, of course, but it's in sometimes you don't need to retain the data in case your project is working very fine and you don't need to check anything further or any details after finishing the updating all of the design points. So I prefer always to retain the data at the first design points in order to check your results. If everything is okay and you don't need to save each design point results, so you can work without the retained data after that. Okay. This is just a simple introduction to our ANSYS Workbench interface. Before finishing, just a small advanced feature here inside ANSYS you can add to your knowledge. There is something called scripting. What is scripting mean? Scripting means in case you want everything you do inside the your workbench file is saved like a code that can be run again, like for example, if we select record journal, it will record everything you want and then it will write it as a code that can be run at any time later in another project. Like if we press on record journal, now it will save this at the location I prefer. It will be a workbench journal file. Like I can write it to be project record. This project record, if we save this on the desktop, it will now record everything you put inside or anything you edit inside your project. Like if we took one of the geometry again and put it here, then if we used one of the meshing and then connect this one to the meshing itself, if we used Fluent instead of CFX and then connect the meshing to the setup. Now if we work with this and then if we return back and go to the scripting, stop journal, now it will stop recording. Okay, let's try to open to run the script. When we go to the scripting and then run script file, it's called the project record. Here you can see that everything is done exactly as what we have made before. This project record is just coding for what is done. It is saved like some lines that if you write a code to import a geometry or connect a geometry to the meshing or whatever, so this part is very beneficial for some advanced problems, like if you want to create your project again from scratch without doing it by your hand each time. You can just record what you are going to do and then everything will be saved and then run again at any time you prefer. Also, if you go to any of this analysis system, you can just update this system, you can duplicate it, you can export one of these systems or multiple systems at the same time. We can replace this system with another one, we can clear all the generated data, we can delete it, we can rename, see its properties or add a specific node. So you have multiple options for each analysis system separately we can export it like another workbench file. So if you have different analysis systems here, but you want one of them to be in a separate project, you can export it and open it alone in another system, in another project. Okay, I wish this video helps you. Let's continue in the next video. I will show you how to draw your geometry in ANSYS basically. Have a nice day.